Welcome. My name is Heuvel. I'm on, in case you wonder how to spell that, it's on the first slide. So I'm currently the head of the Department of Mathematics here at the LSE. We're hosting this event, and it's a great pleasure to see so many of you. We wish that our lectures were always this well attended. Let me say a few words to before we start really with the lecture. So can I please ask you all to put your mobile phones to silent? There will be a recording of this event, and if everything works well with the technology and the sound and everything, there will be a podcast available via the LSE website. So if you ever want to look back at this evening, hopefully you're able to do so. So we have one speaker today, Professor Bernhard von Stengel from our department. He will talk on the topic of game theory and politics. He plans about 45 minutes. After that, there will be time for questions. Sorry. Okay, thank you. There should be plenty of time to questions, so we really prefer not to have any questions during the presentation. Please keep your questions, your remarks, your comments until the end. Okay, so a very warm welcome to Professor Bernhard von Stengel. He's professor here in the mathematics department at the LSE. He joined the LSE in 1998, so he and I are more or less the same generation. I was there 1 year before him. He studied mostly in Germany, but also a time at Austin, Texas. After that, had postdocs in Berkeley and in Zurich, and then joined the LSE. Since then, he has had a couple of visiting appointments in Bonn, in Berkeley, and in Paris, both in Dauphine and École Polytechnique. But most of his time and most of his research work has been done here at the LSE. Now, Bernhard will talk about the game theory in general. That's his specialism. His research is game theory, in particular computational and structural aspects of game theory. So how to actually compute things when we talk about games. But he also has done other things around it, as he will demonstrate during this presentation. So I'm very much looking forward. I'll join you again in 45 minutes.
Thank you. Good hurdle mass. Second one is, does the clicker work? Yes. Okay. So I'm a mathematician, not an economist, as most game theorists are nowadays. And so you'll hear a little bit about mathematics in addition to just game theory. And let me start with a quote by a mathematician, Gottfried Leibniz, who co-invented calculus together with Newton more than 300 years ago. There's a formula down there, which is an important theorem. Don't worry about it. I mean, this is calculus. But what I want to say here is this notation that some of you suffered through, but which is actually very useful. This d over dx and this integral sign, they are due to Leibniz and not Newton, and has persisted. But he was also a polymath. He did many things. And among one of the things, he was a philosopher and had this statement in French, which I thought is a very good opening statement to what game theory is about. And he said, the position of the other is the true viewpoint in politics as well as in morality. And in a nutshell, you could say, this is what game theory is about. Don't look at things only from your own perspective, but think about the situation that involves other people. So that's, if you wish, the main message here. Game theory models interaction about multiple agents, which are called players, and then tries to derive from this model a solution, which is, for example, what is called an equilibrium, which gives everybody a recommendation of how to behave, but everybody, not just you, but everybody from a symmetric perspective, and tries to do so in an impartial way, because something that was only good for you and not for the other cannot be a viable recommendation. And when you look at the game, it turns out very much that the rules of this game matter for the outcome. So in particular, if you can redesign the rules in order to achieve better outcomes, and what then the game theoretic analysis reveals, that's what game theory is particularly useful. And at the end of this talk, I will demonstrate all of these concepts. At the end of this talk, I will also mention that, we should keep in mind that not all rules are written down. In fact, in Britain's constitution, for instance, there aren't. Many things are just conventions and habits, and actually game theory will have to do a lot to incorporate these unwritten rules. But essentially, we play according to certain rules, and that's what constitutes a game. So game theory tries to generalize situations that it encounters, and so I give you a few examples which I have drawn from politics or try to cast in political terms. And one concept is threats, and I will give you here already a little example of a so-called game tree. So this is a situation that, in a very simplified form, models what happened in 2015 in Greece, where there was a big crisis about the government finances there. And the EU was asked by Greece essentially to keep on giving more money to the Greeks and extend their credits. And instead they said, sorry, enough is enough. You have to reform your finances. And so had this option, this move on the right says ask for reform. And Greece didn't like this. They expected, the EU wanted to that Greece accepts this. And that would have mean the most desirable outcome for the EU, but not the most desirable one for Greece. So we have numbers here. The players here have colors. Here we have two players, the EU and Greece, red and blue. And the game proceeds by choosing one of these actions. And at the end, the two players get a payoff each, the red one for the EU, the blue one for the Greece. So this was 1-0 if they would accept the reform. And if it would have been better for Greece to, if the EU would have extended the credit, then say 2 units for Greece and 0 for EU. The most important simply meaning that the EU prefers this one to that, and for Greece it's the other way around. But Greece also threatened something, and that's the essence of this game. It said, we are not going to do that. You can do what you want. We rather quit the euro, which then was called Grexit. So not leaving the European Union, but the euro system, which would have been very painful for Greece and not very pleasant for the EU either. So essentially, Greece threatened to shoot itself in the foot. Now, the normal way you would analyze this game is the following. You say you look ahead. It's called a backward induction and a look-ahead analysis. And then if Greece is put in a situation to accept or refuse, they will clearly accept because 0 is better than -2. And assuming this rational behavior, the EU can either extend the credit and get 0 or ask for the reform and get 1. And so clearly it asked for the reform, which is what it intended. So this is what is called an equilibrium. It's a set of actions, one for each player, that together are optimal against each other. But the interesting part about this game tree is that there is a second equilibrium which goes as follows, which says Greece refuses and says, no, I won't accept those terms. And when Greece does so, the payoff will be -2. It doesn't look very good for Greece. But it will also not look good for the EU, because then Greece exiting the Eurozone would be quite destabilizing for the euro and so on. So they would rather extend the credit and go here. So this is also a stable outcome, an equilibrium. And why is this seemingly irrational action for Greece in fact a good way of acting? Well, -2 is clearly worse than 0. It is because Greece does not have to execute that threat. That's the whole point of the threat. I do something that's harmful for me, but also harmful for you, in order to, in a sense, blackmail you to give me what I want. Now, you can even try to make a commitment here, which Greece tried to do by calling a referendum and said, we will never accept those terms, by eliminating that branch here. And then it seems a clear choice for the EU to actually do extend the credit, except, as we know, it didn't work. There was Wolfgang Schäuble, who was then a very popular politician in Greece, said, well, let's seriously consider getting Greece out of the euro. And then they, in fact, it was a humiliating defeat, and they accepted the reforms because the threat was not taken seriously. In fact, it was not credible. So that was actually the only equilibrium that prevailed. And in a certain sense, game theorists talk a lot about which equilibrium should we choose. This is the one that is more stable among these two equilibria. But it's a typical game theoretic analysis. So what is the essence of threats? I mean, there is an irrational component to them. I do something harmful for myself, but because it's harmful for you too, I induce a behavior that I like. But the main problem with them is, are they credible? And if they're not, you're kind of stuck. So all sorts of threats that the UK makes in current negotiations should be viewed in that light, perhaps. But I want to say also something else. I was tempted to say, I mean, Schäuble called Greece's bluff. Calling your bluff is actually a different term in game theory, which I also want to explain. It's actually used in a different context. Namely, it comes from poker. So where the essence of the poker game is that you have hands and you don't know, I mean, how high they are. The key part of poker, and that's why it's interesting, is that you don't know what other cards the other guy has. If it's a chameleon, maybe not, but so it's not so popular with them. But I mean, if you don't know the cards, you can actually bet on a high card, and the other person can accept that bet and then has to pay if your card is indeed higher, or can fold, and then you get the pot without having to show your hand. Now, the interesting thing about a bluff is, so a bluff means that you pretend to have a high hand if you don't. And the interesting thing is, in game theory, you should actually, the game theoretic analysis says, you actually should bluff some of the time, not all of the time. Why? Not only to gain money when you bluff, but in order to not signal what hand you are, because if you only bet high, if you have a good hand, they always know and they will always fold. So the idea is that if you sometimes bluff, even if the bluff is called, the next time you bet high and have a good hand, the other person might think it's a bluff and thereby chip in and then you get the money. So the game theoretic analysis says bluffing sometimes is good. You should do so randomly. Now, random actions are something that you see in other situations, for instance, in sports. Here is a football penalty kick. And the striker maybe has some favorite corners where they hit particularly hard, but the goalie can jump ahead, I mean, before he even sees where the ball is coming, into the correct corner. And for that reason, it is better to actually randomize actively your actions, because that way, I mean, this is actually optimal play. You don't know yourself what you are doing, because then the other person cannot predict where you go. In fact, you should even sometimes shoot in the middle, because if the goalie either jumps left or right, you will score for sure. So there is an incentive for the goalie to sometimes wait. And so this is a typical game theoretic analysis that says randomize sometimes, but it typically, and this is something I simplify now a little bit, but it most often applies to situations that are win-lose situations, like here in sports, which are called zero-sum games. It simply means one person's gain is the other person's loss. Here, for instance, the probability of scoring a goal wants to be maximized by the striker, minimized by the goalie. And when you don't know what's going on, when you act simultaneously. So that is a typical scenario where we randomize. And so I'm simplifying when it says it applies mostly to zero-sum games. We have a politician in the United States who thinks unpredictability is a feature and probably has learned to act that way in his life. And if he acts strategically, which is debatable, but it also signifies a zero-sum mindset. I mean, because that's where this is most successful. Okay, so now I want to explain a little bit more talk a bit more about the concept of equilibrium. Dominic Cummings says, is Dominic Cummings in the audience? Maybe should be. Government is stuck in a bad equilibrium. What does this mean? Let's try to explain. Let's recall equilibrium means mutual optimal behavior. It depends on what the other person does or the other people do. And now let's give some examples of equilibrium. And I also show you another example, which many of you will know, another example of how you can describe a game. So this is a game table. And it's not a game tree which goes sequentially. It's where people have choices independently of each other. So it's a more symmetric situation. There's not somebody who goes first. And in this case, we have two players and two choices. And the two players are indicated by a row player who can choose a row. It's the red player here. and a column player who can choose a column. These are the blue columns. And then if this is chosen simultaneously, you result in one of the cells of this table. So there are 4 cells here. And the 2 payoffs in there are given in red and in blue, and they are staggered in the following way, that the lower left payoff in red is for the row player, and the upper right in blue is for the blue player. And that way it's unambiguous, and also you see more separately the 2 payoff matrices, as you call them, the tables here, 2, 0, 3, and 1. And when you write it that way, you also see when you draw a diagonal here that the game is symmetric in this case, which means actually if you interchange the players, it's the same situation that you're in. Mathematicians like symmetry. It's also nice to indicate that physically in a sense. So this diagonal is not in part of the game, it's in part of the analysis if you wish. And now we do something else. These numbers are meant to be maximized. So what it means is here 3 is the best possible payoff for the respective player, the largest number. And now I put boxes, so my game theory students will recognize this, boxes around the payoffs that are best for the player in the following sense. So these 2 strategies here are called cooperate and defect. And the whole game is called the prisoner's dilemma, which has a famous story. 2 prisoners who are held hostage, held by the police. They have a crime that they can only be convicted for when they confess, otherwise only for some illegal weapon possessions or something. And if they confess, which in this case means rat on each other, defect, the idea is if they hold tight, means they cooperate, they get both 2, the fairly good payoff. But if one rats against the other, they get an even higher payoff, which is the incentive given here by the police, and the other one goes for a long time into prison. So what this means is if the other person holds tight, well, I would get 2 as the row player if I would also hold tight, but if I defect, if I don't cooperate with my fellow prisoner, I get 3. So that's why the 3 has a box. And similar, if the other person rats against me and I would stay in prison for long, I at least get another prison sentence, which is not as bad because I confess it's 1. So 1 is better than 0, 3 is better than 2. And it's by symmetry that holds for the column player as well. So if the other person cooperates, 3 is better than 2, 1 is better than 0. So in other words, no matter what the other person does, I'm always better off defecting. And this is indicated by a box here that has 2 boxes surrounded by, numbers surrounded by boxes in equilibrium. They are mutual best responses. And the dilemma, if you wish, is that they now defect and they get both 1, whereas if they had cooperated, they would get both have gotten 2. So that's the dilemma here. And that puzzles people a lot, because how can something that is individually optimal be detrimental collectively? And it's good to know such a game. And in fact, it has been called, and I would rather call it a metaphor for the tragedy of the commons, because we see that a lot, and it's in situations where there is a common good that individually is not an incentive to maintain. If you look at, say, grazing in a commons meadow, you don't overgraze, that's good, but if you on your own overgraze, that doesn't harm. I always profit from overgrazing or overfishing, or if you wish, and now an acute problem, global warming, I'm an individual person, would pay a lot of money to insulate their house, and it doesn't almost change anything. But, why should I be the person who does this? But then if nobody does it, we all suffer collectively. You can even apply it to a country. Australia has only 1.3 of global emissions for CO2, but the big coal industry, so they alone will not solve global warming. So it's good to know that this prisoner's dilemma exists, because it shows you the need for acting collectively. In fact, commons themselves have been studied by, for instance, Elinor Ostrom, in practice have unwritten rules that enforce cooperation and not exploiting the commons on a small scale. Grazing rights in the Alps, water levels in farming in America. It does not scale up, I think. But so it's worth being aware of this, because we should know that we need, individual incentives will never be enough. We need collective action. On the other hand, I think this is an overrated game, because there are literally tens of thousands of papers written on this, trying to solve this dilemma somehow. And for instance, you play it repeatedly, and I mean, that is not the way to solve it. I mean, we cannot solve global warming by playing that repeatedly. We don't have time for that. In fact, a colleague of mine, now deceased, Richard McKelvey, ran a lab in Caltech on people running this repeatedly, trying to see whether they would evolve some cooperation over time because it would be beneficial to them. And at some point, his lab was out of order because the systems administrator had left. It was his last day without leaving any password information or whatsoever about these computers. And which decent person would do that? And Dick McKelvey said, I think he has been exposed to too many of these games where you, cheat at the end. Okay, so I think overrated, but nevertheless worth knowing. So I look at a couple of games more like that. Here's another one. It's a model of brinkmanship, which is called the game of chicken. And again, we have two players. And let's suppose they can act aggressively or cautiously. For instance, approaching intersection, but also maybe in negotiations about the future of the EU-UK relationships. So here are the numbers. And again, it's a symmetric game. You see, so let's look only at one of these numbers. If you act aggressively, if both act aggressively, they crash. They both get 0. If both are cautious, they both get 1. But if one is cautious, the cautious player gets 1, and the aggressive player, the aggression pays off, and they get more, 2. Okay? So it's the same way the other way around. By symmetry, the aggressive player gets more than the cautious player. And so if you look at the best responses, it means it's very easy. You should be cautious if the other person is aggressive. Yeah, because if the other person is aggressive, left column here, you as the red player should be cautious. 1 is better than 0. But if the other person is cautious, you should be aggressive because you get 2 rather than 1. So we have 2 equilibria here. And they are essentially obviously, one is cautious, the other one is aggressive, but we don't know which one. It is a symmetric game, and yet the 2 equilibrium behaviors are not symmetric. The 2 players do something different. And it's not clear how to select them among them, and it's good to know that also the situation can occur, even in a symmetric situation. You could still not say one equilibrium is worse than the other, because in one equilibrium, one player does well, and in the other player does well. So this is not yet a concept of bad equilibrium, which I want to illustrate with another example. Suppose for simplicity, we have only 2 Republican senators, obviously we don't, but in the US Senate, who can decide whether to impeach their president or not, and they only succeed if they do so collectively. Obviously, we need more senators, but let's suppose it's only these 2 people. And if they both impeach, which is what they actually plan to do, it's 2, it's good for them. If they discharge the president, it's 1 in either case. And if the other one discharges and you impeach, you are in kind of not a good situation because you're exposed as the person who, has not even succeeded in the impeachment. So the payoff there is 0. So we again have seen 2 is better than 1, 1 is better than 0, and now we have 2 equilibria, in fact, 2 symmetric ones, where they either both impeach or both discharge. And you see that the bottom one this is really a bad equilibrium. It is an equilibrium in the sense that they are stuck in there. No person on their own can improve. You would get worse to worse. Both would go from 1 to 0. Although they should be up there, and if they would be up there, then it would be also a stable situation. So this is what you would call a bad equilibrium. And now the obvious question is, why don't they play the good one? Shouldn't it be obvious that they play the good one here? What in this situation is possibly good about the bad equilibrium from their perspective? Can you see? Maybe the story tells you. The one to discharge is completely risk-free. You get 1 point no matter what the other person does. But if it's very risky, because if the other person doesn't, so if you impeach and the other person doesn't, so like here, you impeach, the other person doesn't, you get 0 instead of 1. So this is the safer choice of 2 cowards, if you wish, but it's completely legitimate. If you're in that equilibrium, you better behave like that. Okay, so this is a real example of a bad equilibrium. And you see already with a few numbers here, you can play a lot of games and analyze situations that are intrinsically rather different. Now, whenever I present some simple games like that, people ask me, where do you get these numbers from? as a game theorist. And of course, I mean, so the idea is that these numbers are payoffs to be maximized. And the long and the short answer is, I mean, you need some numbers like that to express a consistent preference, one that has a unique best solution. Often these numbers don't matter in their own right. I mean, they just mean this is better than something else. A bigger number is better. Okay, so it doesn't even matter exactly what the numbers are as long as they indicate this ordinal preference, what is better or worse than another outcome, as we have seen in the previous examples. And now I want to turn my topic to Brexit and try to answer the question whether we can actually, if people have, groups of people have consistent preferences in terms of numbers, can we also consistently aggregate them? But before I do that, I cannot resist, because I'm a mathematician, talking about numbers and talking about Brexit. I think we should talk a bit about Brexit numeracy. So I ask you a question. Which of these numbers is largest? 350 million per week. That's what we pay to the EU. Let's give it to the NHS instead, right? 18.4 billion per year. Or, and this is the most shocking number, £5.30 per person per week. Which is biggest? They're all the same. Which sounds biggest? The top. That sounds like a lot. 18 is smaller than 350, 530 per person, that's almost nothing. In fact, this is the gross payment. Half of this comes back to the UK in the form of agricultural subsidies, science, you name it. So it's like £3 per person per week. That's a beer. I mean, people did not dare to say how small this number is. That would have been on my battle bus. £3 per person per week, the best deal ever. And the problem is people were not numerate enough to challenge what 350 million per week are. They are scared by these big numbers. So anyhow, numbers with Brexit, what I tell now a story is, and I worked a little bit on that, a bit of a story that tries to say, let's look at numbers that we at least could agree on, and then we have an aggregation problem of what aspects of Brexit are there. And let's assume for simplicity that we have 3 Brexit options, a hard Brexit, or 3 options about Brexit. Now, one of them has passed. But hard Brexit, get rid of all ties. Soft Brexit, comply with rules, or decide to stay in the EU, maybe after calling a second referendum. So there are many aspects, and I would say that they, this is just a sample, and we can debate that. But I think they reflect to some extent what has to be looked at when you look at these options. So one of them, which is I think very important, is respect the result of the first referendum. So clearly hard Brexit and soft Brexit, I mean, do well on that. The referendum did not say which kind of Brexit we have, one of its main problems, and staying in the EU clearly is not. Then we had this problem in Northern Ireland. So that's why we have 1, 1, and -1. So big numbers are better, -1s are not so good. A hard border in Northern Ireland would be endangering the peace there, -1 for a hard Brexit, but soft Brexit and staying in the EU would tie on that with, say, 0. Economic impact, worst for hard Brexit, a compromise for soft Brexit. That's what the EU is about. For some people, even hard Brexiters would probably accept that ranking. Then we have here the row of sovereignty, whatever that means. But I mean, let's say you have the complete control about your own laws. Here you can do more of that. Here you have to follow the rules of the EU, so it's the ranking goes downwards. In terms of British world influence, debatable, but we could say Britain is better off as part of a big player, and influence is what the player does. On its own, totally maybe less so, and if you only have to follow rules, but not even part of the club, that's worst in this scenario. So at the moment, let's just assume that these are rankings, and let's accept them. We can debate them, but just I thought these are kind of plausible. Now I chose them, of course, with something in mind. Now, for instance, you could add them up. Doesn't give you a clear preference. They're all tied here, like it's 1, 1, -1, 0, and so on. You see the middle row is much of a compromise. It's the middle in 3 of the cases where the others are more extreme. Now, so totaling up is a good way because you would then get a total score, but of course, I mean, then you can debate how much weight you should give. And that, so for instance, if you say, respect the referendum result, which was a very important issue for many politicians, and understandably so, if you give that more weight, then all of a sudden, I mean, then this, for instance, if this has double the weight, you add this twice, and you get a sum 1, 1, minus 1, and then clearly EU is no longer an option. Staying in the EU is no longer an option. You have these two ones left. If you say, obviously the referendum was about sovereignty, then of course you give that more weight, and then out comes the hard Brexit as your solution. Clearly, you have to decide about these weightings, and moreover, and then it's even not easy to agree, obviously, and moreover, they even depend also on the magnitudes of the numbers themselves, because if this minus 1 was a minus 2, again, you would get a different sum, and so on. So what I now want to do is I want to propose or discuss a mechanism with you that would only look at the rankings. So we do something else here, and we compare these options pairwise, so one with each other. For example, the first one, let's compare hard Brexit and soft Brexit. So on the first row, this is a tie. That's what I said. Both respect the referendum result equally. In terms of Northern Ireland peace, clearly the soft Brexit comes out better, and in terms of economy. So that's 2-0 for soft Brexit, but then in terms of sovereignty and British world influence, it's the other way around. So we have a tie here. Still no good decision. Let's do this exercise for soft Brexit, where they're staying in the EU. Soft Brexit is clearly respecting the referendum result. We have a tie in Northern Ireland peace. So far it's 1-0 for soft Brexit. Then economic impact better for the EU, 1-1. And you see this counting doesn't depend on the magnitude. It just shows which is better. So it's, in that sense, it looks more robust. Sovereignty, it's the other way around. And so we have 2 on both sides. So again, this is a tie. Now, there's never a tie when you have hard Brexit where they stay in the EU. That's which we compare next. So it's an odd number of criteria. No ties. There must be a winner. Let's find out the winner. Respect the referendum result for the hard Brexit. Northern Ireland peace for the EU, 1-1. Economic impact, 2-1 for the EU. Sovereignty, 2-2. British world influence. If we accept this, it's 3-4-2 for the EU. Okay. Sure, why not? Now, this is a prelude to something else. I want to simplify this table as follows. And let's aggregate the first 2 rows. Let's say, respecting the referendum and result and having peace in Northern Ireland is something about acceptability of this, about this decision. So if we add them up, we get no ties anymore. So we have 0 for hard Brexit, 1 for soft Brexit, the most acceptable version, which we can perhaps accept just like that, even without this addition process, -1 for staying in the EU. And status of Britain would, if you add this up, so this is these 2 numbers, 1 plus 0 is 1, 0 plus -1 is -1. So that soft Brexit comes out worst. And in the EU, it's kind of tying up. So that's the middle outcome there. And so let's just use these 2 criteria to make it a little simpler. So acceptability as the first row and status of Britain as computed so far like this. And let's put the economy back in. And you can say, well, these are criteria. You could also say maybe these are factions in parliament who think this is what this issue should be decided upon, or this is what should be given most weight when we look at these decisions. The sum is still 0, which it better should be because these were previous sums, so it doesn't affect the sum. So again, we are still in the same quandary of not having a unique sum. So I go back to the previous exercise and compare how they go against each other. Now it should be 2-1 or 3-0 because we have no ties anymore. And now let's see, hard Brexit where the soft Brexit. Well, soft Brexit is more acceptable and less economically harmful. Not so good on status, but it's a 1-2. Soft Brexit is clearly better than hard Brexit. Okay, soft Brexit, we're staying in the EU. What? You want to be a rule taker? Well, you better stay in the EU. And economy is always better. Okay, it's more acceptable, but clearly, soft Brexit is now clearly beaten by the EU. So, the EU is the clear winner, isn't it? Absolutely. Well, let's give it a try. Acceptability, hard Brexit beats EU. Economic impact, EU is better. Status of Britain, hard Brexit is better. What? We're in full circle. So if you have an argument for doing a hard Brexit, you have very good arguments to saying soft Brexit is better. Argue with soft Brexit, we might as well stay in the EU. Yes, but then look, I mean, hard Brexit dominates the EU. So now if these are factions debating, they can talk until the cows come home. And that's maybe what happened in Parliament last year. I mean, because every alternative had a better alternative. Despite the fact that each alternatives and each individual rankings were completely strict and consistent. The aggregation is far from. With this criterion, pairwise comparison, it is not. So I didn't invent that. This is called the Condorcet paradox, and it's from the Marquis de Condorcet, who died in the French Revolution in a prison cell, poisoned, but he was a thinker about politics and came up with that. In fact, in a general setup, you might have heard of the arrow impossibility theorem. It's something that cannot be avoided in certain situations unless you have a dictatorship or something. So, I mean, this is all related, and this is about the theory of social choice, not so much game theory, but it's about aggregating preferences, so it is some game theory. Okay, now, I said in my announcement that I thought Brexit was a strategic mistake. I still think that. You could argue that Cameron took a gamble and just the outcome was the wrong way. Maybe he was playing games that way. I think he overestimated his persuasive abilities. And I think there was a litany of strategic errors mostly because the conservative politicians thought about the Conservative Party and not about the wider implications of their actions. But, I mean, that's, yeah. So let me say what are strategies in terms of game theory, and I think that's a useful concept. So that's the question. I once saw Boris Becker in an interview, and I loved the answer. What is your strategy for beating your opponent? He said, strategy? Well, I try to hit the corners of the tennis court and hope he doesn't. Perfect answer. Play well, tennis well. George W. Bush, strategy is to make up your mind and stick to it. True. That's what he said. Now, this is actually the opposite of what the game theorist thinks strategy is. I mean, if you have a very simple game tree, yes, maybe that's the way George Bush thought about the Iraq War. 2 actions, deterministic response. But game trees, in practice, there are more options and more possibilities. And then game theory says, actually, and this is a well-defined concept, a strategy is a plan of action for every situation that you might find yourself in. So strategic thinking means to anticipate the situations that you can be in and be prepared to act accordingly, which requires, of course, or imagining a game tree which is sufficiently realistic, but it also requires, not just making up your mind or ignoring all information, but being able to react and then see what's happening, and not only what you can do, but also what the other players might do. So I think it's worth, emphasizing this concept of strategy. Even though it is abstract, it means what you do in each node of the game tree, which is the situation where you find yourself in. It's a good concept. Okay, I said the rules of the game matter, and let me look at an example from as well. And I want to then move on from these rules of the game about voting rules, where I will try to debunk the concept of an irrelevant vote. So here's a rule from union law, as far as I know. I'm not an expert, but I think in the UK the rule is as follows. If a union calls a strike, it has to call a vote among its members first. And the rule is that a majority of these votes have to be in favor of the strike. And at least half of the members of the union have to be voting. Not in favor, but there is a quorum. If people are not sufficiently interested in the issue, it doesn't count. Now I want to show why this is a problematic rule, at least if you think in terms of democratic participation. let's imagine there is the following situation. It's known, polls or whatever, that 28% of the union members are for a strike, 20% are against it, 52 are indifferent. If you are against the strike, should you cast a vote against? The answer is no, because the best way to torpedo the strike is to not vote, because then the quorum will not be met. If you now vote, and maybe it goes up to 22%, above 50%, you have lifted above the quorum. And so what this rule actually does, if people think strategically, and this is not so hard to understand, I mean, then it actually discourages participations by the members. And if you, because this doesn't work, so if you want to induce democratic participation, you should replace the quorum rule. So you should still say, of course, the majority of the votes has to be in favor. But then the vote in favor of the strike has to be at least, the 25% that we're aiming for, or even a higher quote. But at least you would then not to be disincentivized, to vote if you're against. You would then participate in order to express your opinion, which is what we want in democratic participation. This will probably not be changed by the conservative government, but at least it's an example of how the rules of the game induce behavior that is intended or unintended. That's another question, but it influences strategic behavior. A second, this is from the BBC website, is of course the rule that we have in place for electing constituents, members of parliament. The UK has 650 constituencies, seats, and the rule is very simple. Each seat has a list of candidates. The candidate with the most votes wins the seat. So here we had in London, Westminster, and cities of London and Westminster, Chuka Umunna ran for the Lib Dems, got 30%. The Labour candidate got 27%. The Conservative candidate got 40%. 40% was the plurality, not the majority, although probably Lib Dem and Labour would not have voted preferred Conservative, but Conservative won. The opposition was split. So that's how the rule works. One of the implications is that we have a stonking majority for conservative parties, for the Conservative Party of their members, although they only have 43.6% of the vote. And so for instance, in Scotland, it's even more. The Scottish National Party the SNP has 45% of the vote, but more than 80% of the seats, because they're almost always, in all these constituencies, the largest party. What I find amazing on the map on the right is, these are the changes. White is no change, and this is what has been gained. For example, London is this thing down here, 73 seats, 2 gains for Conservative, 1 gain for Lab, 1 for Lib Dem. It actually cancel each other out. What I find amazing about this map is how little actually has changed. Less than 10% changed seats. Almost everything stayed the same. This is the famous red wall that broke down and created a lot of blue seats. But essentially, most of the seats, nothing changed. So you could argue, and in fact, you see the results. For example, the Lib Dems got 4.2% of the vote, more than last time instead of 11.5%. So that's a gain, relatively speaking, of 60%, and they lost a seat. They have 12 seats now and had 13 before. Of course, Labour lost a lot, but the Conservatives did only gain a lot, despite the fact that the proportion was not much higher. Oh, the Greens is even more extreme. They went from 70% relative gain. In another country like Germany or the Netherlands, the Conservative would not have a majority here. It would be Lib Dem and SNP already would be a majority relatively compared to the Conservatives. And it would be a very different system. And the Lib Dems, of course, complain bitterly about the system, except that it probably won't be changed by a winning party. So let's think a little bit about, this is not so much game theory, but it is something that has to do with how people think about voting. So is proportional representation better? Now, the prime example, I think, is the Netherlands. They have 150 seats, and if you have enough votes to gain one seat, you will have that seat in parliament. So there are lots of parties. There is no, I mean, they now have a coalition that forms government of 4 parties. Why? Because no 3 parties have enough votes in parliament to form a majority. There is a party for the animals, which has not illegitimate aim of improving the life of farm animals. They have 3 or 4 seats. They're never in government, because otherwise they would have to compromise on their principles. But I mean, you have these parties. Now, what I want to say is, we would change the rules of the game massively if we introduce that system. I'm not saying we shouldn't, but we should be keeping in mind what for, because then you shift the problem of who becomes the government to the formation of party coalitions. And if you have all these parties, you haven't voted for a coalition, you have voted for a party, and you have shifted the problem of forming government to parliament. And the problem is that people have to be used to that, and here in Britain, they're simply not. I mean, we had a coalition government between the Lib Dems and the Conservatives in 2010, and the Lib Dems got clobbered for breaking their principles, like introducing tuition fees, because people didn't realize that you have to make compromises. They could have, I mean, it's simply not used to the system. And apart from the fact that it won't be changed, one has to think about what one wants to achieve when one introduces the system. So I think, I mean, population needs practice with coalitions already, and surely with referendums. In Switzerland, they have referendums all the time. They're much more used to this. I mean, I don't think this country was used to referendums. And I think one should look maybe at New Zealand, who introduced proportional representation to dire warnings that this would lead to be an ungovernable country. It's actually the opposite happened. They consulted before about this. They also had a very good way of solving an urgent issue, their flag. People hated their old flag, and instead of deciding we hate the old flag and call a referendum on that, they said, let's decide on the new design first. So they had a vote on what would be, if we change the flag, what should be the new flag look like? And then they had their most favorite design, and they ran it against the status quo. Keeping the old flag, guess what happened? They kept the old flag. So that should have been, because I mean, Brexit was not meant to be a democratic choice. Otherwise, you would have decided what it means and discussed it. And instead, it was saying we just have a blanket out, in or out, in order to scare people, and people were not scared enough. So that was part of the mistake. Let me conclude with another strategic aspect about voting, which is called the voting paradox. And that means, why do you vote at all? Because if you think strategically, when would you vote? You should think about the situation where your vote matters. For example, I mean, people have studied this. When you are in a jury in the United States, I think the death penalty has to be awarded by unanimity. And by this rule, it means that if you are the decisive person, that means you're the only one who thinks the person is innocent. You might ponder whether it should be your weight or the weight of the 11 or whatever number other jurors should be what counts. And so it's actually detrimental in a strategic sense to have that rule compared to a majority rule. But let's think more practically. What is a pivotal voter? One who changes the vote. Well, here's a piece of news for you. Your individual vote never matters. Never. And I'll tell you a story about this. I hope I can. It's about the LSE here. We had, must have been 7 or 8 years ago, there was the introduction of student fees being raised from 3,000 to 9,000. And this was not a fixed number. It was an upper bound, a ceiling. So the LSE was debating whether we should have 9,000 student fees per year or 8,000. Why? LSE was rich enough to say, I mean, we can afford this. We send a signal. It doesn't have to be 9,000. And £1,000 is quite a bit of money for a student per year. So there was a heated debate. The school leadership wanted to have 9,000 to give more scholarships, of course. And so I had changed my mind. I said, I think it should be 8,000, gave an impassioned plea, and then there was a vote. And it was 86 to 85. in favor of 8,000. So I felt great. I was pivotal. Because if I had changed my mind, not only anybody of these 86, if they had changed their mind, they would have swayed the outcome. So you feel very important in this election. By the way, all the losers, the 85, none of them is pivotal by definition. If you lose an election, your vote is lost, no matter what. If you could have changed it, but because you lost, I mean, what could you have gained? Okay, so now, so I was pivotal, and then the chairperson said, well, this vote is too tight to be decisive. I said, what? The only time I vote matters, it doesn't? I was completely incensed. So then it was not clear if it had been the other way around, yeah? I mean, if it had been, it was not a tie, it was a clear vote. And so I thought, why should I ever come to these, to these academic board meetings? Of course I go, because so voting apparently was not meant to be a decision mechanism. By the way, guess it was meant to achieve some sort of consensus. This was only a recommendation to the council. Guess what happened? 8,500, which was actually a proposal at the board meeting, but it was dismissed as too, whatever, extreme, I don't know, ridiculous. Anyhow, and then it went up to 9,000 a year later. I mean, but, I mean, so I think it's a myth to say you vote because you change the outcome. There is no such thing as a lost vote, even in first past the post. Of course, I live in a constituency where there's a clear majority for Labour, Hackney, 80% or whatever. I will never make a difference, but I still vote. Not because I think it makes a difference, but because I should participate in this process. And so I don't think people do vote strategically in that sense, and for that matter, not even tactically. They might not cast their vote for the least likely candidate, but they still vote for an unlikely candidate. So all the strategic thinking that should be going on here, which is the voting paradox, doesn't apply, I think, to voting. So this is my last slide. I've given you a little tour of what game theory could achieve. And I think it's good because it helps you think about the other players in the game, helps you think ahead. But we have to do a lot to do in game theory. And one of the main problems is that our games tend to be unrealistic in many respects. The first thing is because people don't think, I mean, Conservative Party leaders are not the only ones. There's too much wishful thinking going on with strategic thinking. You think too much in terms of your own tribe, your own perspective. And we have to think of how to model that adequately to understand interaction that's going on. The second aspect is the whole individual maximization story, which I tried to show you with the prisoner's dilemma and with the voting, is also not capturing what is going on. It does to some extent, but not fully. There is something like public spirit, civic duties, responsibility for the commons that we have to try to incorporate in our models to be, I mean, this is some ray of hope in many situations, and we have to understand them. And what I said, I mean, and which is clear, I mean, we should, of course, think about the rules of the game, change them if needed, but we also should keep in mind what rules they are, because even the unspoken rules matter, and there are many of them around, and we should take them into account. So this is lots to do for game theory. So thank you for your attention.
Thank you very much, Bernhard, for I think a very interesting and hopefully inspiring talk. So, just the name of the game for the next half hour, roughly, is your chance in the audience to kind of ask questions to Bernhard about his presentation or anything else you kind of think is related to it. Please, there's 2 roaming microphones. Wait until you get a microphone before you ask your question. Keep your question short and to the point. And also we'd like, if you don't mind, to kind of say, before you ask your question, say your name and where you're from. Yeah, whatever you feel that means. If you prefer not to, fine. But it's kind of, it's for us in the audience, it gives, and for Bernhard, when answering the question, it gives a bit of an idea of where is your question coming from. Okay, I see one person up there in the far top. Let's go there. And
there will be more.
Hi, my question is about, I'm a member of the public. My question is about artificial intelligence. As algorithms run more and more of our lives and make more and more decisions for us, with most people not understanding how algorithms work, I know it's very far away from the specifics of your talk, but will AI and will algorithms be capable of morality?
Of?
Morality.
Morality. Will AI and will game theory and will algorithms based on that be capable of morality one day?
So it's a slightly left field question, but kind of, yes. I mean, what if, artificial intelligence, algorithms more and more used, will they change morality? That, I understand, is your question. You want to answer that?
Yes, but, so let me say one thing. I mean, not so much AI, but game theory is running a lot of these algorithms. So if you Google something, you get ads displayed, and these ads are automatically auctioned to the highest bidder. And because when you click on that, you have to pay an amount of money to Google, and Google makes most of its revenue, I think, like order of 70 billion or more. I mean, numbers are all from exactly these ads, and they have been designed by game theorists, and they were worth their money. So, of course, AI plays a role, but if you want to define what is a moral outcome, I mean, is it one that is the consensus of what people are? I mean, this is, I mean, I would pass it back to the philosophers to define morality. But I think, I mean, do you expect me to give you the answer as a game theorist? I mean, game theoretic tools are meant to help us in structuring our decisions, try to base them on something, try to validate them. And I think it's a good tool in that regard. And I think it is used, that's what I was trying to say, in whatever algorithms you use already. So in that sense, I mean, no, I mean, they're not moral, but they're part of the game. So I'm evading your question, but I think it's not one that has a clear-cut answer.
Okay, thank you. There was a question, the next one here. Yes, he was there. Sorry. If you can say your name, if you don't mind. Okay.
Yes, hello. My name is Chen Hao. I'm a history student at UCL. And I just want to ask that, what do you think about the future of cooperation in the two fields between political theorists and game theorists, that to solve the problems like collectively about the challenges of game theory? And do you think that it's actually possible to work out a coherent argument of the final optimum outcome of the game, like finally for human beings as a whole?
I feel very privileged to, I mean, they ask these kind of questions.
Can you summarize the question? How are you interpreting? So,
if I understand it correctly, you want to design a rule to get the optimal outcome for mankind. I mean, is that, I mean, a short summary? Well, let's look at the prisoner's dilemma with global warming. I mean, we clearly have to find ways of being able to solve this collective problem collectively. And it cannot be left to individual incentives. So we have to design a system that makes it incentive compatible, if you wish, to strive for, I mean, reducing CO2 emissions and so on. So that's what I would say we should keep in mind. Be aware that when you say optimal, there's a big difference between something that is socially optimal and something which is individually optimal, which is one of these concepts of game theories that comes about. So it's, yeah. I mean, this is what game theory can help you with. It will not solve mankind's problems, but it helps you thinking about them.
Okay.
Can we have a less philosophical question, maybe?
Yes, a less philosophical question. Can we just kind of... the person there in the back, the back row, I think he was slightly faster.
Hello, I'm Howard from Goldsmiths. What is the use of game theory? Like, are there politicians or are there examples of maybe politicians, advisors using game theory and it's sort of working to their ends? Are there examples of that, or is it a kind of a theory that there aren't great examples of in practice?
So very good question. Is it actually used really by politicians?
So, I mean, I think it's used metaphorically. If you're a game theorist, you would write down a game and write down the rules, and you try to develop a game tree and think about what your options are. And I think some politicians do that more than others. I mean, Angela Merkel has been called a chess player because she's thinking a little bit further ahead than other politicians. But is she a game theorist for that reason? Yes. But I mean, it's relative. It's not I think that's what I try to illustrate here. This is not a magic tool that if you analyze everything, then you control the world. It's a matter of understanding the world. It's a tool to understand patterns in interactions and try to see what its pitfalls are. For example, that you can have more than one equilibrium, or that there are individual incentives contradicting the common good and so on. So you should be aware of that. You will not be able to manipulate it using game theory, I think.
Okay. There's a
This
question.
person has been waiting for a while.
Thank you. I'm Naveen. I come from India. Basically, I live and work in Germany. My question is, I have studied mathematics. I've done my engineering, and then I have also studied management. And I see importance of game theory. But my question is game theory sufficient enough to cover each and every variable? And especially when we know that, as human beings, we are more emotional than rational. Does game theory account for emotions? And if not, then is it useful?
Okay, very good question. So the question is, does game theory account for emotions? And I would say yes, because these preferences, these payoffs are not money. They represent a preference. And if you feel emotional about something, and maybe feeling about sovereignty of Britain is an emotional thing rather than an actual thing, that is reflecting in a certain preference. And as long as this preference is consistent in some way, it doesn't have to be constant, maybe it evolves over time. Game theory tries to take that into account. But I think the concepts of game theory are sufficiently general to account for emotions as part of your preference, and there should be.
Okay. There was a question here at the front.
Yeah, sort of.
Well, the fourth row. The person in the white shirt, please. Can we maybe have a few female voices as well? Next, sorry, down here first. Sorry. Hiya. Okay. Yeah.
Hi, I'm a sixth form student. Do you ever factor in the cost?
Can you please repeat that first bit?
I'm a sixth form student.
Sixth form student.
Do you ever factor in the cost of obtaining perfect or near perfect information? As in, when the costs of assessing every possible outcome outweighs the probable benefits of finding the most optimal choice in a game?
Well, that's very much a topic of game theory. So to repeat the questions, is it always worth getting perfect information in order to make optimal decisions? In fact, if you're George W. Bush, you prefer not to get any information. And I'm not kidding, actually. Information is costly, even in writing down the game tree. When you have lack of information, you have fewer decisions to combine because you can react to less. And this is actually a good concept. And there's lots of studies that say, how can I even operate in partial information, or how can I quantify the cost of obtaining information because it might be possible to make fairly good decisions even in the absence of perfect information. So a lot of game theory is concerned with exactly the value of information in a strategic setting. And we have experts sitting here, my colleagues who work on that. So game theory is very much addressing that question.
Excellent. Now we go to the person here. Yes.
Hello there. I'm a PPE student, and I'd just like to ask, would you be able to... Pardon? PPE, philosophy, politics, and economics. Yeah. Would you be able to model a system of altruistic behavior through the prison's dilemma, either through an asynchronous or synchronous interpretation of it?
The question is whether you would resolve the...
No, would you be able to model a system of altruism?
A system of altruism. Okay, so I mean, there is a lot of, as I said, I mean, stories about the prisoner's dilemma that try to explain altruistic behavior. There is no conclusive answer. As I said, there are models that say play the game repeatedly, because cooperation is obviously beneficial. So altruism is not even, I mean, unselfish here. The evolutionary models, you name it. I think as a research question, there is something else going on in the prisoner's dilemma. You think you should cooperate because if you think that way, the other person should also think that way. And that's, of course, the wrong causal connection. But it might be not wrong in the sense of how we think. I mean, the fact that we can be predicted in our electoral behavior from very small samples shows that we are maybe not as free-willing individuals as we think we are. So in a sense, when I think I vote for this candidate, I think that many people who think like me will do the same thing. So I think this is something that is true, but it's not well understood. It's something for psychologists, philosophers, and game theorists should try to incorporate that into their model. I posed it as a research question.
Excellent, thank you. Can I have a female voice? There's a... Yeah, I can't. Good.
Hi, I'm a sixth form student. I was just wondering, if voters did act strategically and vote tactically, how different do you think our political landscape would be?
It's not clear. I mean, so let's assume they vote tactically. They really, I mean, go on the website and vote for the candidate that is most likely to beat their favorite enemy or something. I think the vote would have come up differently in London. Let's try to... Yeah, I mean, there were a few marginal seats that would have been won by Lib Dem or Labour against the Conservatives, quite clearly, but I don't think it would have made a huge difference in this scenario. I mean, if everybody had voted tactically, that's what I was trying to say on the subsequent slide. I'm not sure the outcome would have been that different, honestly. But that's my personal opinion. I mean, yeah. I mean, we have to, if we want to introduce proportional representation, for example, we have to think of what we want to achieve that way. Maybe less polarization, for example, more compromises, more coalition forming, and so on. But then that has to also be a process that has to evolve in a way that it will be accepted by the people.
Okay, I see one question there, and then we go down here. So, yes, please. That one, yep.
Hi, it's Mohammed from Pakistan. I got a quick question around the different scenarios that you put out there and how to weight out the different variables.
The Brexit stuff?
Yeah, indeed. So presuming we can put that into different scenarios, different outcomes that we want to look at. So I guess the question is around, surely we got enough data and rational way of thinking to analyze and put a weightage towards each one of these. Why would there still be a ambiguity around that?
So what I try to say here, I mean, so this, I made them up, of course, but I mean, I thought they're kind of plausible. And so it's not based on data. What I'm saying is we can see them in different ways. We can see them as, I mean, these are weights in a certain sense, but they also represent weights you could interpret as opinions of people in parliament. Yeah, I mean, there's groups of people in parliament that have different preferences and think of this as the important issue. And then if you say, I mean, in parliament there are, I mean, I don't know how many, 50 people for whom this is paramount, and another people who do this, of course, they also have some outcome in mind. But I mean, if you have all these things, you could look at them as weights, as represented as people in parliament who vote. And what I was trying to illustrate with this example is the fact that if you vote one against the other, you can come full cycle. That's what this story was about. Full cycle, 2-to-1 each time.
I guess my point was around why is there opinion-based and not necessarily weight on the historic data available?
Well, I mean, do you propose to have a mechanism that polls everybody on these criteria and then... that was not the point of the exercise. I mean, We don't have a mechanism that's, I mean, it's interesting. If you have issue-based, decision-making, people in social choice think about this and paradoxes that can occur and how should we aggregate and combine these preferences in the end. It's a good question. But this was not the point of the exercise. I was trying to lead you to, rather than confronting you with this from the beginning, I was trying to make it a little bit more plausible that this could be a ranking according to which a third of the voters in parliament, say, base their judgment on.
Okay, thank you. Can we go to the front here? Second person. Thank you.
Thank you very much for the interesting talk. My name is Elica, Bulgarian. I studied politics in the University of Glasgow, then went to live in Argentina for a year and currently working in finance in London. So my question is, as a game theory beginner, how does game theory look at uncertainty and the unknown? So what I saw was illustration of the unknown, what we don't know. So let's say a lot of the time you had a choice between X or Y, but when I lived in Argentina, most of the time the choice was X or the unknown. So I just wonder what kind of shape does the unknown take? Is it like a positive connotation? Is it a zero? Is it a negative one?
Yeah, that's a very good question. Obviously,
Can you repeat?
I'm sorry, I repeat. The question is, how does game theory deal with the unknown, in the sense that if you don't know these numbers exactly, for example, how do you get the numbers? How do you treat that? There are two ways of doing that, a complicated way and a more flexible way. The complicated one would be to try to describe a probability distribution on the possible values and then deal with expected values or whatever. Or the simpler way would say, let's try to look at different numbers that could come out and see how they affect the outcome. So if you have a game and the numbers could be different, you don't know them, play with the numbers and try to see whether the outcome actually depends on them. And that's an excellent question. Whenever you do game theoretic modeling, this is the most important step in the whole analysis. What is your model like? Is it accurate? If it's not accurate, the whole analysis is void, because it's anyhow a simplification. Okay, so my vote would be, play with the numbers and see where the critical values are that would then come out with different answers. And here's a thing in my own domain. I have a program where you can enter games and play with them and try at a mouse click what the result is. So that's what I'm working on for exactly that problem. If you don't know enough game theory to analyze all these things, but maybe you can still model the game and click and see what the result is. So that's my justification for doing that kind of research. Okay. So it's a good question. It's very important. How accurate is your model?
Okay, far back, I think there was has been a little bit further, all the way up to the top. And then there's one here, and I'll come back to you.
Hi, Daniel, graduate student at LSE. And excuse my voice, I think I'm slightly ill. I would be interested in your opinion on the downsides and upsides of Professor Dr. Bernhard Selten's scenario bundle method in strategic thinking and planning. I hope it is not too specific, and I excuse if it is.
So the question is, what is my opinion on Professor Selten? What?
The upsides and downsides on his scenario of the scenario bundle method in strategic planning.
Random method in
scenario bundle method.
I still don't understand.
Scenario, some kind.
Scenario bundle method.
Scenario bundle. Oh. To be honest, I knew Professor Selten, but I didn't know of the bundle method. So
yeah, I think it's very specific.
Okay.
But Selten was an important person in the sense that he came up with solutions 10 years ahead of his peers. The mathematics of his it's not very sophisticated, but when you look at, contributions, pioneers thought of these things first, and he was a pioneer. So I'm not sure about the bundle method, but
Okay, we have one person here, and then we go back up there.
Hi, David studied at KCL. You mentioned, I'm drawing on 2 points. First, that you mentioned the more people were used to the rules of a political system, so the rules of a game, like referenda, that could maybe influence how they act, or at least how they react to a problem. So, and then you also mentioned that people tested how people acted to a game theory over time. So I was asking, how did people in a prisoner's dilemma with 2 equilibria, after they played it many times, how did their responses change?
So 2 questions. I mean, the first one is, well, I mean, you said, I was saying people should get used to the rules of the game in order to, obviously it will affect how they play the game. What I want to say is, if you want to change the system, you have to be aware that people use it in the way that you intend and that it's right. And for instance, in proportional representation, you have to get used to the fact that when you form coalitions, first you need coalitions, and secondly, that there will be compromises. And that you have to evaluate on how good the parties achieved their individual aims in that compromise. So I think it's in order for the system to be good, people have to get used to it. Now, the second question is, you said in a game, the prisoner's dilemma has only 1 equilibrium. It is bad, but it's only 1 equilibrium. Can I paraphrase your question in the sense that can we look at a game which has 2 equilibria and which one comes about? This is studied by experimental economists. And it seems that when people learn to play the game, equilibrium behavior starts to become more prevalent. There are other concepts, like minimizing your losses or something like that, that are equally justifiable, but equilibrium is actually not so bad. We have some experimentalists here that you can ask who could give you more definite answers, but I think, I mean, this is exactly what is being studied, and game theorists are aware of the need to validate models. I think the danger is that they're often too abstract, because I mean these little games are not, they're over-interpreted. I mean many situations are not like that. I mean they are too artificial, and I think a lot needs to be done to make game theory more realistic, and setting people into labs and letting them play artificial games is not the sole answer. You have to evaluate how, you have to test that. I mean, and that's what experimental economists do. They try to work on that for a while. Pioneered by Bernhard, by the way.
Okay, 4th row from the top. No, a little bit further down. Yes, please. Thank you.
My name is Adela Gooch from much maligned North London. Thank you for your talk, Professor. You mentioned Dominic Cummings. How has he used game theory to achieve the electoral result and the referendum result? And I suppose I'm asking, what is the interface between game theory, psychology, and psychological manipulation?
I don't think he has used game theory in the referendum story. I think when he now blogs about bad equilibrium, he has seen too many TED Talks. There are no simple answers. I mean, I think he has some mindset, but it's not one that is dominated by game theory.
Okay. I see lots of hands. Can we, I think, a little bit further down, please? No, you, down. This way. Yes. And then we go to the one in front.
Thank you very much for the lecture. My name is Verena. I'm from Germany and studying at LSE IDS. I've got also a very specific question. It was very interesting as an IR approach, applying game theory on politics. And my question would be, in the case of the Ukraine crisis, I'm not sure if you have ever made up your mind about this, but how Russia and European Union or the West should react on this crisis?
The Ukraine crisis, can you solve it?
Well, I mean, it's, so are we talking about Crimea okay. So, I mean, Russia has violated international law by annexing Crimea. thought could get away with it. The European Union and the West reacted with economic sanctions, but didn't start an all-out war as, I mean, they could have said, I mean, we have to show these guys. I mean, clearly this was, I mean, would have been an inappropriate response. It would have been an incredible threat to say, you must not violate this. I suspect the Crimea will stay in this state for a while, and the question is whether the next leader in Russia will think it is to their benefit to at least give out eastern Ukraine or something in order to regain the better status for Russia. I think the West is reacting in a decent way, but it's obviously, I mean, not a good situation in all senses, right? I mean, violating rules like that and so on. So how should I be the person to decide how this can be resolved? But I mean, I think the West is trying to respond in a measured way and saying, let's not repeat this kind of action. Or, I mean, it's not paying off. And maybe it was not signaling enough beforehand, and maybe it might not have happened. But that's counterfactual thinking. I mean, game trees are like that. They have parts that are never reached. But that's also ex post thinking. That's in retrospect, we are all more clever. I don't have an opinion.
Can I get the person in front? Yep. Thank you. And then we go.
Thank you. My name's Ian. I'm a consultant in public health. And I wondered if we could use game theory to devise better strategies to get parents to vaccinate their children.
So the question is, can we have better strategies to vaccinate their children? Well, so I'm actually, I mean, I sat in this chair was Esther Duflo, who presented her book, Better Economics for Hard Times. And I've read it by now. It's an excellent book, and she has done field studies on how to induce vaccination. And they found that you can surprise, I mean, she said very well that there are these ideologies who said, I mean, if vaccination is good for you, people should pay for it. Other people said, I mean, you should give it away for free. In fact, it turned out that if you incentivize people by rewarding vaccination, and in fact, completing the course of vaccination, which is even more important with an extra bribe, if you wish, worked fantastically. So it's good to have these field studies to improve vaccination rates, and I think they should continue. And she did very valuable work in analyzing that. It's not too good to do this by theory, but to try to figure out what works.
There's one here at the front. I don't know.
I should probably start to.
Yes, we kind of. Yeah, we really like to stop in about 5 minutes, so there's a few kind of time for a few questions. So please.
Thank you very much for the talk. Andre, UCL. Last September, there were like city-level elections in Russia, and the leader of the opposition proposed a system of strategic voting. Basically, in every constituency, there was a program which told people who is like the which candidate has the most chances to win against the government party in the exact constituency. It was relatively successful at the end, and my question is, what kind of systematic changes can we see if the number of this kind of systems would increase?
So in Russia, it was apparently a system of information, I guess. I mean, that led to relatively successful tactical voting, if I understand this correctly. And your question is, how can we improve that? Or what is the question?
If some system can count of which person is potentially, can potentially win against, for example, the leader of the country, etc.
Yeah, I wouldn't propose a system, but I think if that worked well, I mean, the fact that they, I mean, asked people, let's keep it going. I mean, it sounds like a good idea, but I'm not. So, I mean, don't think of game theory as the magic bullet. I mean, it's a way of thinking about things, and its main feature is that it's not just some tool like artificial intelligence here and there. It tries to give a structural framework of thinking about interactions which have common patterns, which can apply in various scenarios. And a secret thing that, I mean, then you can manipulate the world with. It's a way of understanding, and that's how I try to present it. I always wonder whether
good.
It should be a concluding statement.
To the person here, yep, thank you.
Hello, my name is Paul. I'm from South Africa. My question is, how reliable is previous data in predicting, well, to use past data for future predictions? How long can you use that data, and is it reliable enough to make predictions with?
It sounds like a question. So the question is, how reliable is past data for future predictions? Ask a statistician, sorry. But yeah, I mean, sorry.
Yeah.
It's not a game theory question. I'm not trying to.
Okay, I see too many hands, so I'll go to...
Let's collect 2 or 3 more and then we stop.
Well, yeah, 2 or 3 more. We go to the back a little bit further. Yep, the person. Yes, please. And then there's another question there we do, and then I think we'll kind of call it in. Please.
Hi, I'm Martha. I work for an investment consultant.
Sorry, can you repeat that?
Yeah.
I'm Martha. I work for an investment consultant in London. You talked about the prisoner's dilemma as being very studied a huge amount, and obviously it's classic game theory, but what parts of the field are still evolving or perhaps understudied?
Well, which parts are understudied relative to the prisoner's dilemma? So the prisoner's dilemma is a model, okay? And it is, I mean, the key question there is, how can it be that something which is obviously better is destroyed by selfish behavior? And how can we remedy this? Maybe by playing this repeatedly, maybe by introducing all sorts of other concepts, evolutionary models, and so on. And as I said, in that sense, it is overrated. I'm not saying it's as an explanation tool. I mean, what is understudied? I mean, this is a matter of opinion, in the sense that we are all game theorists and we try to do something interesting. I think the biggest danger, probably in any academic profession that is trying to be applied, especially to the social sciences, is that you think too much in your own frameworks. And that is, for example, here the game trees, the payoff maximization, these game tables. These are basic tools, and then there are other tools for cooperative games, which, I mean, try to quantify how coalitions form and so on. And the danger is that you see the world too much in these terms. And so in order to answer what is, some of these things are overstudied. So for instance, there is the problem of equilibrium selection. You have a game, and then you have many equilibria. And Reinhard Selten, together with John Harsanyi, turned it to a quest of finding the perfect equilibrium point. And there is a notion of perfect equilibrium. I'm not kidding. I mean, that says this is the way that everybody should arrive at. That is the unique solution if you just think long enough about the game. And this is misleading because it assumes that the game is given as this. There are so many other factors. So what is understudied, in my opinion, is what are the actual interaction problems that we face that should be solved with game theory but aren't yet. And of course, this could open the door to all sorts of wishy-washy theories and so on, but I think that we need to have more interaction with the actual interactions problems that we have and to think out of our own mindset. I mean, I was saying this because this equilibrium, in the end, they had more concepts and more theories to find the right equilibrium point than they had examples to apply them to. And that's not, I mean, that's not the way it should be. And it degenerated into some sort of very academic exercise. And there are some areas of game theory that have still too much in this idealized thinking. We need to be more practical. But that's a personal opinion. I don't want to put down any game theorist who wants to be a high church philosopher in that regard. So.
Okay, I think this is actually a very good point to kind of stop when an academic says we should be less academic. Okay, can I thank Bernhard very much again for